And then we use JMeter for performance testing as well, and that's also a once-a-day process. And then we've developed some tests to help there. MeterMaid, which is a way so we can write all those tests in XML, and a MeterMaid Maker, which is kind of a way to automate building some of the tests. And then we also have another tool called Tidbit, which allows us to build big, huge data sets to throw at our application so that we can do performance load testing underneath that. And like I said, there's a URL there of all of the link to the tools. They're all available under the same licenses that the parent projects are licensed under, and they're all downloadable. We have up on GitHub repositories. Just as important as automated testing is non-automated testing, right? So automated testing is I kind of define more as like defensive testing, right? Because you're basically defending to make sure things don't go wrong, right? You're defending yourself from things going bad. But the non-automated, the manual testing, I kind of see the more of the goal of that is to make sure that what you're doing should actually be right, and somebody actually looking at the app to see what's going on. I have yet to ever see a PC World review of an application where they say, your unit tests were terrific. Instead, they'll say, wow, I don't know why they use this color, or wow, I don't know why they use this UI to convey this. It's completely unintuitive. Those are the sorts of things that pop out, as your apps are getting reviews and people are using it. So having somebody that can concentrate on that, not necessarily from a does it meet the specs perspective, but a product manager or just a user to say, hey, this intuitively makes sense. This fits in with the flow of your application. This is how a user would expect to use it. Having that in place is so, so crucial to success. And we try to do it at a lot of different levels. We do it early in the code review. We do design reviews. We get our partners and customers involved, and we get early beta cycles out there just to get things in front of people and get feedback and know what the expectations are and what the users expect. The earlier you get in the cycle, the better. So, okay, quiz. What kind of car is that? What kind of Buick? Yeah, a Grand National. Yes. Ah, and you even picked out the small thing. How were you able to tell it's a GNX? True. Well, I was going to say if you could tell the GNX, because if you can look on the side very carefully, it has extra air vents. My father-in-law loves these cars, and they're like and it's like his bread and butter. My wife thinks they're the ugliest things known to man, but they're really kind of unique cars, though. And you're right, they're like production-wise, they could outrun Corvettes. And actually, to be honest, production-wise now, like a stock one today could probably outrun a lot of the muscle cars in the street today. And the unique thing about them is they're not the classic big block V8s that from the power cars of the 70s and everything. It's a 6-cylinder, and especially the white one. Well, the white one isn't a good example. My father-in-law has one that's very similar to that, but it's they call it the Regal Limited. It's basically the same engine and everything internally, but if you look inside, it has like the big cushy seats and everything in the column shifter. It looks like a car your grandma would take to church on Sunday. But it has a big old turbo on it and everything, and it can run like 15 seconds in the quarter mile. But the unique thing about these cars, I find, is you can do very little to them and just kind of tweak. You can add very few aftermarket parts on them, maybe just do kind of little tweaks and things like that, and get the car to run like ridiculously fast. But he has a friend of his that does a lot of work on them for him, and he like knows the cars like the back of his hand. It's really sick. And the one thing that when he's talking to people, they like bring his cars to him, like, yeah, I got this GN, I really want it to run, I want this thing to run fast. And the first thing he says is, how fast? There's a lot of varying degrees of fast, do I want a 10-second car? Okay, well, you're going to have to go down this path if you want to go down that way. Am I happy with a 12-second car? Okay, well, you can do these simple things and get to this point, So you have a lot of varying degrees of where fast ends up at. And I think kind of with, like, when we kind of look at Sugar, it's kind of the same way, right? If we have an enterprise client that's deploying, I don't know, 10,000 seats or whatever, you just throw out some retarded number, their definition of fast is going to require this set of hardware. If you're deploying in your mom and pop business and your definition of, and it's only 10 people using it, your definition of fast might be go down to Best Buy and get a reasonably fast computer and be happy with it. So there's like varying degrees, or go to Dell and buy one of their $7.99 rack server specials or whatever. So there's a varying degrees of fast of where you want to be. And a lot of it also comes with cost, right? If money was no object, of course the 10-person place would clearly build out a huge cluster farm with a big squid cache in front and all the web servers and stuff, build something to rival what Yahoo or Facebook is doing. But they just that budget doesn't make sense. So when somebody ever comes and says, I want this to go fast, it's not, you can't just say, oh, well, we'll just do this. You need to buy this server. You need to buy that. There's not like a bullet, there's not like an easy answer to it. It's, okay, well, let's talk, what do you define fast? How many users, how many of this do you have going on? And then that kind of helps build the story. From that standpoint, it makes it more difficult for us because we write the application whether you're 10 users or 10,000 users. And we kind of have to make it so the application can go either way depending upon, what have you. So we do simple things on our end to help the performance. So we start by like the simple things. Don't write slow code. Try to cache as much as humanly possible and where appropriate and not too much because also too much caching is just as bad as not caching enough. Try to minify the CSS and stuff and not try to do weird complex SQL queries because it just never turns out well. And then give the sysadmin the power to take the next steps. Our enterprise editions allows you so you can do master-slave MySQL. We have a lot of configuration options for features that kind of will be a little bit more heavy on performance that you can turn back if your instance isn't needing it. If, like I was talking earlier, if we see you have an external cache available, let's try to use it. That gets up a huge amount of speed to begin with. And then provide like those performance guidelines to say, if you're in this category of users, this is what you should be doing. And we find that kind of, those sorts of things get the, and then we're able to get the feedback from our customers of saying, what do we need to do to make it even better? And they can give us feedback on what we need to adjust. And like I said, I was talking earlier, we use JMeter and a lot of instance analysis to kind of figure out where all that stands. And in addition, we use a lot of ad hoc testing. So there's some really good PHP profilers. Xdebug's one. Another one's Xprof, which the Facebook people came out with, which is also really good. And we use a combination of those. We use some Firebug as well to kind of analyze and see where performance is, how many resources are you loading, and things like that, and learn to optimize from there. So what the heck have we learned? What are the lessons we've learned in this process? One, the best thing to do is to kind of set your expectations up front. What is your matrix of what you'll support? And then make your code fit within that and be flexible as possible. You have customers going to be all walks of life, so you have to make sure that you can adapt to them reasonably well and be able to provide a solution to them. Make the customization process easy, make it less painless, make it intuitive, and make it documented. Make sure your testing goes across everything, not only from the automated standpoint, but then you're also looking at it from a product review standpoint to make sure what you're doing actually makes sense. And focus on making your code, using the best practices possible for your code, and then let admins kind of take the next step from there as they need to. And with that, I have still a couple minutes. I'll have the slides online on SlideShare. As you can tell, I'm from Ohio, and as you can see, we're not bitter at all. But I'll open the floor to any questions.
You just have to raise your hand to ask a question, by the way. No
yelling
or anything like that required.
Yeah.
Looks like you covered everything. Oh, this
That's
is
good. Or either that or people flash to sleep. I've heard some giggles. OK, now I see a hand.
How do you see the difference between what you're doing for stuff that you're going to download versus stuff that would be, say, resident on a web server, or let's client server, thin client server?
So more, I guess, can you kind of more, like, what do you mean different in?
No, different in the sense of, do you find that, the process you go through, the tools, the strategies to adopt, specifically in terms of characterizing performance, or maybe just given the overall test automation, the stuff that you apply different, doing,
Right.
running on a client versus a thin client server.
Right. The theory behind it's kind of the same. I mean, you're still trying to, the advantage, I guess, in a client server sort of thing is oftentimes you might be better controlling one half of it versus the other. I guess in a way, in a client server, the thin client server can actually be a little bit more complicated, right? Because then you're actually having two components that you're testing. You have wherever your server is installed and everything going on there, but then you have your clients, which can be a lot more diversified, and you can have a lot more crazy stuff going on. So the same methodologies apply. I think it just gets complexity because you have multiple components you're having to deal with and all of the multiple interactions. But in theory, the same principles apply. Obviously, there's going to be different tools that you're going to apply to it, but from a theory standpoint, you're wanting to kind of basically look at it the same way. You want to break apart, your different sorts of stacks that you're dealing with. You want to make sure that, you're fully looking into what's in the underneath environment, taking advantage of it where you can, and not stepping areas you shouldn't, and those sorts of things. So yeah, I think basically the same theories definitely apply in that realm as well.
Would some of the tools that you had mentioned up here not be a good choice if you are looking at things like server?
None of these probably would be very good because a lot of them are either specific to web applications or PHP. Jenkins would probably be good because it's a continuous integration tool. And anybody who's wanting to do continuous integration, I would recommend using Jenkins. It's probably the #1 project out there, and it works with just about every language. And it has a great plugin and everything community around it. But as for everything else we have is much more either web application specific or it's PHP specific. But yeah. Right. Yeah, but Jenkins probably, if you want to use that to kind of do your CI automation, I think that's a really, really good tool to use.
Any more? Seeing none, I think a round of applause is appropriate.
Thank you.